Hello everybody and welcome back to lesson 4 of unit 4. This is going to be a fairly straightforward lesson, shouldn't take us too long. There is a lot of homework. As you can see, this is all going to be homework for you, this question on the worksheet, but this is not an incredibly complicated or difficult lesson, and it's talking about basically the standard form of a quadratic relation. I didn't mention this in one of my previous videos, but the standard form is basically the quadratic relation when it's given as the form that you might be used to seeing it from the previous unit. That is the form ax squared plus bx plus c. So if you want to see examples of a standard form, it's like this, or pretty much any one of these questions over here. You can see that you have an x squared term, an x term, and a constant term, and sometimes the constant term might be absent, which is fine. Like, for example, this here, there's no plus c, there's no constant term, but that's still considered to be in standard form because you have an x squared and an x term. We already mentioned if the x term is missing, that's actually in vertex form is just missing the x minus 0. The axis of symmetry will be equal to 0 is what that means if the x term is missing and you just have like 3x squared plus 5, for example, or something like that. But again, the standard form is by far the most useless form, as in it does give you a bit of information, but not a lot of information about the parabola. It is useful in the sense that it's the form that parabolas are most often given in, and so you will have to know how to convert the standard form into either a vertex form or a factored form we'll talk about later, but you might have to convert it into a vertex form. But for now, we're just going to talk about, okay, fill in the table of values given these two forms. And the most important thing is we need to know where the axis of symmetry for a standard form is. If we're not given that, like I said, the form on its own doesn't give you a lot of information. So you go down here, it's right there. The standard form is useful to determine the y-intercept and the direction of opening. So if we look at our first example, which is 2x squared plus 8x plus 5. If we take a look at this example, really, and if you say let x equal 0, so I want to find my x-intercept, or sorry, my y-intercept, which is the value where x equals 0, I get y equals 2 times 0 squared plus 8 times 0 plus 5. Always the x squared and the x terms will be 0, so we can just cross those out, and you get y equals 5. This is my y-intercept, or just the c value. That's why the y-intercept is always a c value, because when you substitute in x equals 0 and you solve for y, y will always be equal to c. So you do get the y-intercept from the graph, and you also get the direction of opening from our a value. The a value is the same as what we've seen in our vertex form. If you look at our vertex form, ax minus h squared plus k, and you compare it to ax squared plus bx plus c, this a and this a are the same whichever form you write it in. So the a does give you, okay, it's same as the vertex form. If the a is positive, it opens up. If the a is negative, it opens down. If the value of a is greater than 1, it's a stretch, a vertical stretch. You're like making the graph skinny. If the a value is between 0 and 1, is a fraction that's lesser than 1, it's a vertical compression, which means you're making the graph wide. And it's very similar to what we talked about in the last lesson. It's the same a value, and this standard form will give you what the a value is just by looking at it. But apart from that, it's not good for much else. So especially for graphing, just knowing that it opens, what the a value is, and knowing what the y-intercept is not really enough to graph the function. We can't just graph it as easily as we did with the vertex form. Remember, vertex form, we automatically got the vertex and we used our step values to easily plot a graph We sometimes had to multiply step values by a, but other than that, it was very easy to plot the graph. Here, we need another piece of information. We need what the axis of symmetry is. And when you're given the axis of symmetry, usually you want 5 values. In the middle value, that's the x value you're going to put in over there. So I don't want to draw this table again for this one. X, Y. The axis of symmetry, whatever that's given, is always goes pretty much in the middle of the table. And when you're taking the other x values, you're going to take points that are around the axis of symmetry. Whoops, -3, -4, -1, and 0. So again, the axis of symmetry is the middle value, and then you go 2 on one direction and 2 in the other direction. So this would be like 2, 1, 4, 5. And those are the x values you're going to take. Because again, we want values that are centered around our axis of symmetry, because we know that they will be symmetrical in their working. And we'll do one, and we'll kind of use that to fill in this table. We'll solve one table throughout. Now again, I want to find my y values, and I'm going to do that using the table of values. Or actually, I just need to do it for one, and I'll show you why. I just need to really find the vertex, because that's why we put it in the middle, because this is our vertex. We will remember, hopefully, that the axis of symmetry is just my x coordinate of the vertex, right? So the key here is I'm finding the vertex using my axis of symmetry, and I'm putting that value in the middle. So my vertex, to solve for that, I just have to sub in the x value that I know from my axis of symmetry. So -2 squared is 4, times 2 is 8, minus 16 is -8, plus 5 is -3, I believe, is the y value on the vertex. I'm just going to make sure I'm doing this right. And similarly, I'm going to find the y value for here. -2 times 3 squared plus 12 times 3 minus 11. I know this is not really the way that it's done in the table, but I'm not sure whether you're using the shortcut yet to solve it. So we're just gonna go ahead and do the table form, I think. Yeah, okay. Never mind. I'm sorry. Once we found, okay, we're gonna, 3 squared is 9, times -2 is -18, plus 36, minus 11. So -18 minus 11 is -29. -29 plus 36 is 7. Right? So that was that. And now that we have these values, I'm going to, okay, let's, again, you can plot, so now basically we're exactly at the point where we were in the previous lessons. We have the vertex, we have the a values, we can just use our step method. So we know that our step is going to be 1, 3, and 5, right? So here we only need 2 steps. We need a 1 step and a 3 step going this way. This step will be 1 and 3, and of course we have to multiply by the a value. So our step values are actually, instead of 1, 3, 5, our step values are going to be 2, 6, and 10. So we're going to step here by 2, and then another step by 6. Step here by 2, another step by 6. So if we look at this y value, it was -3, and I'm stepping by 2. So I'm going up 2, so -1. This will also be -1 because this is also a step of 2. Then I step 6. So from -1 I add 6. I'm going to get +5, +5. And there's many ways to do this. I can just sub in the -1 here and I should get -1 as well. So let's check that. 2 times -1, so -1 squared is +1, times 2 is 2, minus 8 plus 5. 2 minus 8 is -6. -6 plus 5 is -1, like we expected. Again, 2 times 0 squared plus 8 times 0 plus 5. This is just going to be equal to 5. And by symmetry, because I know this is the axis of symmetry, by symmetry, whatever values I get on these two will be the same as I get over here. This will also be -1 and 5, because I'm just going up by 1 or down by 1 on my x-axis or my x values, right? So I don't really have to calculate that. And if you understand the step value idea, again, our normal step values are 1, 3, 5. My a value here is -2. So I'm going to multiply all these numbers by -2 and get -2, -6, -10. So I'm stepping down -2, another step -6, stepping down -2, stepping down -6. So from 7, if I take away 2, it's, +5. I take away 6 is -1, and I get the same values here. So after that, it's just, we've done this before, it's just, putting in values and labeling the graph properly. So -2, -3 is over here, and then I get -1, -1, 0, 5. And so by symmetry, I can automatically plot these points, and then I will just draw a very bad graph, but again, my apologies. X equals -2, axis of symmetry. My vertex is -2, -3. And the graph equation is actually y equals 2x squared plus 8x plus 5. And that's my completed graph. And the same thing I'm going to do for this one. I'm going to plot the vertex first. It's over here. And then I know it's 2, 5 and 4, 5. And then it's 5 and 1, -1, I think. And once I have my points, I'm just going to, oh, that's much better. Not so much, but oh well. My vertex is 3, 7. X equals 3 is axis of symmetry. And my equation is y equals -2x squared plus 12x minus 11. There we go. And that's our graph. So again, we didn't really learn anything fundamentally new here. We just understood that once we were given the axis of symmetry, if we were to draw a table of values, we always want to find the vertex. Again, basically, we took the standard form, we were given our axis of symmetry, and the first step we did was to find our vertex. Always, that's the first step. Once we find our vertex, you can either put it in a table of values where you're taking, values that are immediately to the left and right of the vertex, and then by symmetry, you just have to do 2 substitutions to find your y, and you can automatically get these values. So as soon as you get the 2 values to the right of 3, in this example, you will get the 2 values to the left of 3 as well, by symmetry. Or you can kind of make use of these step values that we talked about in the previous video, where our standard step value is 1, 3, 5, and you have to multiply that by the a value to get your step values for this graph. And then you just fill in your table, plot the points, and you can complete the graph. That's basically it. Like I said, it's not a very complicated lesson. We're not really doing anything new because, as you'll see here, when I ask you to graph things in standard form, I will give you the axis of symmetry for this lesson, because in the next lesson, basically what we're trying to do is we're trying to go from the standard form like this to the vertex form. But the final answer is we want to find the vertex. And this does take a bit of time to do, so this will be like for example, like a 4-mark question. So if I just asked you to graph the function and I gave it to you in standard form, I will give you the axis of symmetry to help you graph it, of course, unless there's a big question. I say I'm giving you a question. I'm not really making the test anymore, Mr. Tremoli is, so I'm not really 100% sure what kind of questions there are going to be because of the new assessment system or the changes to the assessment system. But don't worry too much about that. Just make sure you're having a good understanding of this unit, because this unit especially will come up again in grade 11 and grade 12, and it'll get more complicated. So it's important that we have a good understanding of factoring from the previous unit, especially, and this unit, just understanding the ins and outs of a quadratic relation. So again, I'll leave you here. I don't think any of these questions are particularly difficult. They're very similar. Axis symmetry is given. You're just going to find the vertex first. So for these questions, you don't have to put a table of value. You just have to find the vertex. The x coordinate is already given because that's the axis of symmetry. You just substitute x equals 2 into your equation. You find your y, and then you know your step values. 1, 3, 5, and that's going to be multiplied by negative half. So your step values are going to be negative half, negative 3 over 2, negative 5 over 2. And once you know your step values, you can just count your steps and you can plot your points. If you want to do it the pattern way, you know the pattern's like 1, 4, 9. You multiply that by the a value. You could do it that way as well, and you would get the same answers, right? So the pattern is really where we're getting our step values from. So there's that. So again, whichever way you want to do it, it does say the pattern here, but realistically, if you did the step values, it's not wrong, or vice versa. Either way works. So hopefully that was fairly easy, and we understood what was going on here. So all right, I will talk to you soon, and we'll be back with lesson 5. So peace out until then. Stay safe, practice social distancing, and I will talk to you soon.